We are working with a global energy model, which is called TIAM World. And what we have done in Hermitage is to couple our model with other models which are stronger than our model in different fields, so that we can benefit from the strengths of each of the models. So we have coupled our energy model with a climate model to get some more information on temperature, precipitation, and evaporation, which was needed to be able to evaluate the impacts of climate change on the energy systems. And we have coupled our model, our energy model, with an agriculture model to be able to know better about the price of energy crops, which are needed also by the energy system. And it has worked, and we have been able to make different analyses with these coupled models together. First, we have looked at the impacts of climate change on heating and cooling. And for that, we needed some more detailed information on temperature by month, by seasons, for the different countries and regions of the world. So we got this information from the climate model, which is part of Hermitage, Placine. And with this information, we have been able to evaluate what would be the new needs for cooling and heating in the different regions, and what would be the impacts in terms of energy consumption and emissions and greenhouse gas emissions. Because what we didn't know at the beginning of the project was if the increase of cooling, we all know that global climate change might result in an increase of cooling. And we were wondering if this increase of cooling, which means more electricity, more power plants, would result in more emissions themselves, resulting in more global warming, etc. So with our analysis, we have shown that no, there is no feedback. There is more heating, there is more cooling needed, less heating, but no impact in terms of emissions. And there are two reasons. So when we made the analysis, the first reason is that heating and cooling is a relatively small share of total energy consumption in the world. And the second reason is that there is a decrease of heating, an increase of cooling in some other countries, other regions, and there is a sort of balance between both. But it doesn't mean that it is not important at the local level. At the global level, okay, no big impact. But for countries, it might mean quite high challenges for energy planning. For example, in India, India doesn't have needs to heat, but in the future, the cooling could increase a lot, what means more plants, more power plants, more coal power plants. At the opposite in Russia, no much more cooling, but much less heating, less fossil fuel consumption. Europe, mixed. More cooling, less heating, so the results would be mixed. And an impact which has been seen, which is quite important, is an impact on the electricity price. So this increase of cooling results in more consumption of electricity, and especially during the peak periods, like summer days, we observed some high increase of electricity price. So it would mean, in terms of management, in terms of planning, it might mean some new kinds of strategies at the country levels. So as a summary, we would say no big impact at the global level, but important impact at local levels. There are many uncertainties when looking at future climate, when looking at future technologies available, and future economic growth. So in Hermitage, we have looked at the impacts of some of these uncertainties on the decisions to make now, given the future uncertainties. And we have studied different kinds of uncertainties. One was the uncertainties in terms of climate mitigation. We don't know yet, depending on the future climate, we don't know yet if we will have to reduce a lot or not future emissions. So we have made an experiment where we decided that we would know after 2040 what to do. Do we have to reduce a lot or not future emissions? And the point was to analyze what to do now, given the fact, before 2040, given the fact that we don't know what will happen in the future. And for decision makers, it's very important to have this kind of analysis, which is a way of, let's say, looking for a compromise between guessing wrong about the future of reducing a lot or not greenhouse gas emissions. And when looking at this analysis, which is called stochastic analysis, just to let you know, when we have done this analysis with our energy model, with TIAM, we have seen some interesting options emerging from the analysis. The first one is that even if there is a very small probability of having to reduce a lot future emissions after 2040, the model decides to move right now. After 2020, 2030, there are some mitigation options which are implemented in the model in terms of anticipation of the future, even if the probability of having to reduce a lot emissions is only 10%. So meaning better to act now than waiting for the future. Another interesting outcome of the analysis was the role of natural gas. Natural gas as a way to deal with uncertainty. So we observed, in fact, more gas in the energy system, more gas for power plants, more gas for heating, more gas for industries, when we include uncertainties, compared to the cases where we don't include uncertainties. Even if with high mitigation in the future, without any uncertainties, we had less gas than in the scenarios we have done with uncertainties. And so this is what we call a superhedging strategy, meaning gas is used more in uncertain scenarios than in certain scenarios. And why such a result? This is because gas is cheaper than other mitigation strategies, and gas is quite flexible. So this is a good way, a good strategy, a good technology choice to implement where we are not sure about the future. And this kind of results can emerge only when we consider these different possible futures in a unique scenario analysis. As a conclusion of the work we have done, I would enlarge maybe a little bit the discussion on the fact that we have to be careful with numbers. I would say that a number doesn't mean a lot if it doesn't come with analysis, with insights by the analysts, by the researchers. So I would say let's be careful with numbers. It's much more important to get insights from the analysis than just numbers. A second point I would like to mention to conclude our work is the importance of the participatory approach at the moment of deciding about the energy strategies we want to implement. I mentioned before the role of gas in energy strategies, especially when there is a lot of uncertainty. And we know that right now there is a lot of resistance with gas shales. And so I think this is really important to open some consultation platforms to be able to exchange all together about the future we want. And when I say all together, I mean researchers, governments, civil society, industries. It's really important to discuss in the light of the results of a study of a project like Hermitage and many other projects. It's important to decide all together about the future we want. We can't impose any energy strategy without this kind of good governance. And finally, the final word would be for developing countries. We should not forget that there are still 1.3 billion of people without access to electricity and 2.6 or 2.5 billion of people without access to clean cooking. And I think it would be important, and this is what's going on also now in most of the analysis done on climate change, energy analysis. to cover all these issues of energy access by the poorest. We can't avoid this discussion if we want to talk about sustainable development. And initiatives like Sustainable Energy for All are quite important and go to this direction.